All right, so welcome to your practice test for tomorrow. So just going through this, gave this test a couple years ago, so just so you get an idea of what we're looking for. So for number one, we are rotating this triangle with legs of 4 and 6. And we want to rotate around AB. So this side's going to stay put. So remember, we want to do the reflection of my triangle over that line. So it's going to make this triangle right here, okay? And then what I want to do is trace the path that the vertex is going to take. So this vertex is going to come around this way in the front and travel back around to the bottom. And as it spins faster and faster, it's going to essentially create a three-dimensional shape here, which is a cone. And so we want to calculate the volume here. So remember, the volume is 1/3 the area of the base, so pi r squared times the height. And so we just do 1/3 pi times the radius, which is 4 squared times 16. All right, we're basically going to leave the pi out of it because it's the answers are all in terms of pi. So 1/3 okay, times 4 squared times 6, and I get 32. So the answer, oh, not 16, by the way. Get rid of that one there. All right, so it's going to be 32 pi, and there's the first one. Second one, the lateral faces of a regular pyramid. So regular pyramid essentially just means the bottom is going to be have all sides equal. So whether it be a square, okay, and when I connect to the four corners, I end up with triangles, and these triangles have to be equal, okay, because all the sides and the bottom are equal. And depending on how tall or small the height is, changes the sides of the triangles. But these side lengths all have to be equal. These sides. So let me go back there. Okay. So these side lengths here, here, and here are all going to be equal. So these triangles that are going on in the middle there are going to be isosceles. Okay. They vary in size because my height could make this a very small, right, regular pyramid, where now these are small triangles, or they could be tall triangles. The height's going to change. The next one, careful with this one. It is a prism, not a pyramid, so it's not 1/3. So the volume is just the area of the base times the height. This happens to be a triangle, so it's 1/2 base times height of the triangle times the height of the prism, okay? Please make sure we're always looking to make sure our units are the same. They're all in inches. We don't do any conversions, okay? So 1/2, 6 times 4 times 10, and this is going to be 120 cubic inches. Number 4, if we take a rectangle 6 inches long by 5 inches wide, and we rotate it around the longer side, so we're rotating about this side, we want to know what shape are we going to get. Remember, we're going to end up getting a cylinder, okay? So a three-dimensional shape. I'm going to do those in blue. Go back so you can see it. So we end up getting a cylinder here, okay? And the height is going to be the side that stays the same. So that's 6 inches, and our radius is 5 inches. So it's a cylinder, okay? The radius, once again, is 5, and the height is 6 because the 6 stays. The longer side stays. Okay. How many cubic inches in the volume? So remember, a cone is 1/3 the area of the base times the height. Base is a circle here, okay? So it's 1/3 and then pi r squared for that area. What are we doing? Okay, so 1/3 pi times radius 2.5 squared. And the slant height is given. We need the actual height. So we're going to have to do a little Pythagorean theorem here. So remember, 2.5 squared plus h squared is equal to 6.5 squared. We can rearrange this into 6.5 squared minus 2.5 squared is equal to h squared, and we have to square these out before we subtract them. So it's not equal to 4 squared, so be careful. Okay, so 6 point, we said it was 2.5, we said 5. 5, all right, squared minus 2.5 squared is 36, and then we're going to take the square root of that, and you should know that that's 6, but there you go. So 36 is equal to h squared, and we get 6 is equal to h. We took the square. So that's how we're going to find the height. All right, so times 6. And then we're just going to take our formula. Remember, the answers all have pi, so this is in terms of pi. So once again, we do 1/3. Okay, and we said the pi r squared, so it's times 2.5 squared, and then times 6, and we get 12.5 pi. So there's choice 1. All right, last question on the front page here. Surface area of a sphere is given as 144 pi. We want to know the volume. Remember, the volume is 4/3 pi r cubed, so we need r. And the surface area is, without the 3, is 4 pi r squared for area. So we're going to plug the 144 pi in for the SA part. We need to get r squared by itself first, okay? So we can take the square root. So we're going to divide by 4 pi, so the pi's will cancel out here. It's important that you get rid of the pi's when you're doing this. Okay, so 144, and then 12 is going to equal the radius. So come back over here, take our volume formula. It's 4/3 pi times 12 cubed. It's in terms of pi, so it's going to be something pi. So on our calculator, right, we're going to do 4/3 times 12, and this is going to be cubed. Okay, so that's 2304. Okay, 4/3 12 cubed, and then pi, 2,304 pi, and then just units cubed. But that's it. On to the next page. We did this question already, so I will do it anyways. But if you want to skip it, go for it. Okay, but in this question, we have a turbine. It has a volume given in cubic centimeters. We're paying attention to that. We're in centimeters here. The money is given in kilograms, and we have grams, so we have to do conversion, and we have to make 500 of these. So we're going to convert right away to kilograms. So remember, we're going to divide this by 1,000. So 0.00795 kilograms. All right. And then we're going to do our calculation. So as soon as I see that it's a density question or a mass question or a weight question, I'm going to draw my triangle. So the mass or the weight, the density, the volume. We want to figure out the weight here. So we're going to get that. So it's density times volume. So the volume, so the weight or the mass, okay, is equal to 0.00795, right, which is the weight in kilograms per centimeter cubed, times it by 1,015 cubic centimeters. We're going to get left with a weight in kilograms. All right, so 0.00795 times 1,015 gives me 806,925, 8.06925, and that's in kilograms. We're not rounding yet, guys, right? Not rounding to the end. Okay. Now we want to figure out how much money we're making. Okay. So our, we'll say the cost, okay, is equal to that weight, 8.06925, times the cost, which is 0.29, right, for all the kilograms. So our cost for this times it by 0.29 gives us 2.340085. But remember, this is money, so it's essentially $2.34. And then we need 500 parts, so the total is $2.34 times 500. And we get 1,070, and it does say nearest dollar. So that's 1,000, 11,070 in dollars. All right, number 8, walking path down below. Now, keep in mind that I technically have a half circle on this side, okay, and then like another half circle here, okay, and I have the same thing drawn over here. All right. So if we were to take these two amounts, here's this one, and here's this one, put them together, right? We're going to essentially get two circles, right? Okay. So I have this area. If I'm trying to figure out the area, so that's what it says. So local path is modeled below. Each grid is 10 feet. The town, not Twan, awesome, needs to submit paperwork to have the walking path paved and how many square feet in the area of the path. So we're trying to figure out the area, essentially, of this part right here. All right. Okay. So I'm going to get rid of the scribbles there, though. So I'm essentially doing the area of this rectangle, this rectangle, and I have essentially this blue circle, right? And I have this hole in the middle of this red circle. Okay. So remember the radius to go from here all the way out, right? There's two different radii here. Okay. I'm going to draw it going this way. Maybe. So here's one radius. Whoa. Here's one radius. Okay. And keep in mind that that radius is essentially in tens. So this is 30 feet. All right. And there's another radius that is going from here to here, which is 20 feet. So we wanted the difference in those two circles, right, would leave us the area of the red part on the outside here. So if we want to figure out this area, okay, we have to take away the two circles and just subtract it. All right, so the first thing here is we can count the blocks. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90. So this is a length of 90 by 10. And there's two of them. So the area of my rectangle, right, is base times height. So 90 times 10, which is equal to 900 feet squared. So 2 times the area of my rectangle would be 1,800 feet squared. And that's the area in those two rectangles. So we're going to do the area of the, we'll call it the bigger, right, circle. Okay. And that's pi r squared. So pi times, and this radius, remember, is 30. So 30 squared, and that's 900 pi. We're going to leave it in terms of pi for right now. Okay. 900 pi feet squared. And the area of the smaller circle is pi times 20 squared. So that's 400 pi. So the difference, okay, the area of our track here, okay, is going to be the 900 pi minus 400 pi, which is 500 pi. And so the total area is the 1,800 for the two rectangles plus 500 pi for the circles. Okay, and then we're going to add those together. So 1,800 plus 500 times pi. And then we want to go to the nearest square foot. So the next number is 7. So this is going to round this up. So this is 3,371. 3,371 feet squared. And that is our area. All right. Time to finish. So the next one, Teresa has a rectangular pool. So we can draw ourselves a rectangular pool. All right. That is 30 feet long, 15 feet wide. So that would be this side going back and forth here is 15. And it's essentially 4 feet deep. So not drawn to scale for sure. Teresa fills her pool using the city water at a rate of $3.95 per 100 gallons of water. Nancy has a circular pool. So we're drawing a little cylinder here. So we'll put T for Teresa and N for Nancy. With a diameter of 24, so we know the radius here is 12, and a depth of 4 feet. So they both have a 4-foot depth, which is kind of nice. She fills her pool with a rate of $200 per 6,000 gallons. if they both fill their pools 6 inches from the top. Interesting. So we're talking about inches now. Remember, 4 feet is essentially 48 inches. So I'm not going all the way up, right? My water level is about here. Okay. And so this is going to be 48 minus 6. So, which is really 42 inches in depth. All right. And the same thing here. So, same thing here. So 48 minus 6 is 42 inches from the top. All right. We want to know, and it gives us a conversion in cubic feet, so we got to figure out cubic feet here. Who paid more? So we want to calculate out the volume. So the volume of this is length times width times height. So the length, remember, is 30. The width is 15. Oh, we got a problem. We want to convert these 42 inches back into feet. So we're going to take 42 and divide by the number of inches in a foot, which is 12. Okay. And we get 7 over 2, or 3.5. So Control Enter will convert that for you. 3.5. And then this is times 3.5. And I know I want to convert back because this is in cubic feet here. So we got to make sure we're using feet. All right. And so we end up with 30 times 15 times 3.5. So 30 times 15. We end up with 1,575. 1,575. All right, we'll go do the volume over here then next. So the volume here is going to be the same since calculation area, the base times the height is a circle. So pi r squared h. So pi times the radius. Remember, we said is 12 because the diameter is 24 feet. And remember, this essentially, once again, is 3.5 feet when I figure out that amount. All right. And so squared. All right. We're going to keep this in terms of pi, though. So we're going to do 12 squared times 3.5. And I get 504 pi. And this is in feet cubed. So we need to calculate how many gallons. Remember, every cubic foot is 7.48 gallons. So the gallons is going to equal 1575 times 7.48. So 1575 times 7.48. And I get a nice number. Just double checking real quick. There we go. So 11,773.52. 11,773.52 is the amount of gallons. And the same thing over here. Gallons is going to equal 504 pi times 7.48. 504 pi. Thanks. Pi times 7.48. And I get this crazy number. So 11,843.5, say 55. 11,800. Now we also could do is we could leave this in terms of pi, right? Go back up here. And if you don't want to round, get rid of the pi. You get that number. So 3,769.92 pi. Well, let's do that. Maybe. 3,769.92 pi gallons. And then, right, there's a number of gallons. So we think about, go back to Teresa, okay? For every 100 gallons of water, she's paying $3.95. So I have 1,100 or 11,773.52. I'm going to divide that by 100. Okay, so That's how many hundreds of gallons I have, and multiply it times 3.95, and this is going to be her cost. Okay, so cost, so divide by 100. Let's go back up to here. Divide by 100, and then multiply times 3.95. And I get $465.05. So $465.05. Meanwhile, Nancy, right, is filling her pool, and she has this many gallons, and it's every 200. She pays $200 for every 6,000 gallons. So 3769.92 pi divided by 6,000, and then times 200, and that's going to be our cost. And so you'll be able to compare now. So go back up. Yes, keys, thanks very much. Pi divided by 6,000, and then times 200. And we get $394.75. $94.75. And so who paid more? That would be Teresa. Teresa paid more. All right, I will send the next 2 pages later on today. So enjoy, guys.